Hello everyone, today we're going to focus on 2.2 forces. Translational equilibrium, Newton's first law. An object of mass m is hanging via 3 cords as shown. Find the tension in each of the 3 cords in terms of m. And angles are given. Mass is m. Give each tension a name to organize your effort. Tension 1, tension 2, tension 3. Draw a free body diagram of the mass and the knot. So for mass is straightforward, 2 forces acting on it. One is a weight, mg, and tension 3, T3. And we also write for T2, T1, and mg. T3 is the easiest force to find as only 2 forces acting on it. And it is in equilibrium. So T3 minus mg equals to 0 and T3 equals to mg. Now we break T1 and T2 down to components, and adjacent is T1 cosine 30 degree, and cosine 30 degree is 0.866. Opposite is T1 sine 30 degree, and sine 30 degree is 0.5. Now we do the same for T2, 45 degree, and adjacent is T2 cosine 45 degree, and cosine 45 degree is 0.707, and opposite is T2 sine 45 degree. Sine 45 degree is same, 0.707. Object is at rest, which indicates it is translational equilibrium. So resultant force in x component equals to 0. T2 cosine 45 degree minus T1 cosine 30 degree equals to 0. So we plug in the actual values. So T2 equals to 1.225 T1. That's our equation 1. Since it is translational equilibrium, resultant force in y component also equals to 0. So all upward force equals to downward force. T2 sine 45 degree plus T1 sine 30 degree minus T3 equals to 0. Substitute values. So if we simplify, T1 equals to mg over 1.366. Substitute equation 2 into equation 1, we get T2 equals to 1.225 times T1, which is mg over 1.366, and T2 equals to 0.897 mg. T1 is equals to this, and T2 equals to this, and T3 equals to this. 1,000-kilogram aeroplane is flying at a constant velocity of 125 meters per second. Label and determine the value of a weight W, the lift and the drag D, and the thrust F if the drag is 25,000 newton. Since the velocity is constant, Let's say the airplane is flying with a constant velocity. Newton's first law applied, which is translational equilibrium. And that indicates resultant force in x component 0 and resultant force in y component equals to 0. Weight is equals to mg, mass is 1000, g is 10, so 10,000 Newton downward. That's the weight. Since resultant force in y component equals to 0, which means lift force minus weight equals to 0. So lift force equals to weight, which is 10,000 Newton upward direction. And the drag force is 25,000 Newton, tries to impede the aircraft to the left. Since the resultant force in x component equals to 0, so thrust minus drag equals to 0. So thrust equals to drag force, which is 25,000 Newton to the right. Free body diagram. The acceleration of an object is proportional to the net force acting on it and inversely proportional to its mass. So net force equals to mass times acceleration. An object has a mass 25 kilogram, a tension of 50 Newton, and friction force of 30 Newton acting on it as shown. What is its acceleration? The vertical force W and R are cancelled out. The object is not moving vertical direction. The net force is 50 Newton minus 30 Newton, which is 20 Newton to the right. And the net force equal to mass times acceleration. And net force is 20, mass is 25, acceleration equals to 0.8 meters per second to the right. 1,000 kilogram aeroplane is flying in perfectly level flight. The drag D is 25,000 Newton and the thrust F is 40,000 Newton. Find acceleration. Since the flight is leveled, resultant force in y component equals to 0. And the resultant force in x component equals to thrust minus drag force. Thrust is 40,000 and drag is 25,000 and the net force is 15,000. Net force equals to mass times acceleration, and the net force is 15,000 and the mass is 1,000 and acceleration is 15 meters per second. A 25 kilogram object has exactly two forces, F1 and F2, applied simultaneously to it. What is object's acceleration? Resolve F1 into its component. X component is adjacent, so 40 times cosine 25 degree, which is 36 Newton. Y component is opposite, that is 40 times sine 25 degree, 17 Newton. Then net force in x component is only 36 Newton as we have only one force in x component. F net in y component we have two forces, 17 plus 30, which is 47 Newton. Then F net squared equal to F net x squared plus F net y squared. That gives us F net equals to 59 Newton. Then from F net equals to MA, net force is 59 and the mass is 25, acceleration is 2.4 meters per second. 25 kilogram object resting on a frictionless incline is released as shown. What is its acceleration? Free body diagram. Weight is downward. Reaction is perpendicular to the surface. Frictionless, so no frictional force acting on it. Break down the weight into its components. Since this angle is 30 degree, this is also 30 degree. Break down the weight into its component. Adjacent is mg cosine 30 degree. opposite to the 30 degree is mg sine 30 degree. Move. Readjust. R and mg cosine 30 degree are perpendicular to the path of the crate. They do not contribute to its acceleration, so they cancel out. Therefore, the net force is equals to mg sine 30 degree, which is equals to ma. And they cancel out. Acceleration equals to g times sine 30 degree, which is 5 meters per second per second. What is its speed at the bottom? Now we need to find a speed. We found that its acceleration is 5 meters per second per second. We're gonna use timeless formula to find final velocity. So we need to find displacement. Initial velocity 0. We are looking for final velocity. And we need to find displacement s. We have opposite and we want hypotenuse. So from trigonometry, we use sine theta equals to opposite over hypotenuse. Opposite is 6 meters. Hypotenuse we are looking for. So hypotenuse equals to opposite over sine theta, which is 12 meters. And we plug into a timeless equation. We can find the velocity equals to 11 meters per second. A 100 Newton crate is to be dragged across the floor by an applied force 60 Newton as shown. The coefficient of static and dynamic friction are 0.75 and 0.6 respectively. What is the acceleration of the crate? Okay, so we have the free body diagram, weight downward, reaction force upward, and applied force F, and friction force. Static friction will oppose applied force until it is overcome. Determine if the crate even moves. Therefore, find the maximum value of the static friction and compare it to the horizontal applied force. Horizontal applied force is this one. That is F cosine 30 degree, and F is 60 Newton. So horizontal applied force is F cosine 30 degree, and that's 51.96 Newton. Maximum static friction force is on the doublets, and the coefficient of static friction is 0.75. Normal force is found from, okay, now we need to take a look at the y component. Applied force, the y component is opposite, so that's F sine 30 degree. And since the object is moving horizontally, the resultant force in vertical component is 0, which means R plus F sine 30 degree minus mg equals to 0. From here we can find R equals to 70, and then we plug into our static friction formula. Coefficient of static friction 0.70 and normal force is 70, and we get 52.5. Maximum static friction 52.5 Newton is larger than the horizontal applied force 51.96. Therefore, the crate will not even begin to move. If someone gives a crate a small push of how much it will break loose, what will its acceleration be then? Horizontal applied force is still same. So horizontal applied force is adjacent. That is F cosine 30 degree. F is 60 Newton given, which is 51.96 Newton. Dynamic friction force is coefficient of dynamic friction times the R. And reaction force is still 70 Newton. How do we find that? Actually, we have done that. Applied force has vertical component F sine 30 degree. Since the object is moving horizontally, the resultant force in y component is equals to 0, which means R plus F sine 30 degree minus mg equals to 0. If we substitute, we should get R equals to 70 Newton. We have done this in previous slide. Now we plug into this equation, we get 40 Newton. Horizontal applied force is larger than the dynamic friction. The rate is accelerated. So F net equals to horizontal applied force F cosine theta minus the dynamic friction, which is equals to ma. And plug in the values. Acceleration equals to 0.996 meter per second.